for the panelists, be sure to unmute yourself before your time comes. And Jeff, if we're showing the wrong screens.
Yeah, that's why I have this over here. So we're
Okay.
good. Oh, you know what? Thank you for that.
Yeah.
All right, greetings everyone. Welcome to today's webinar. I'm your host, the bright and shiny Jeff Sandine. When I'm not surrounded by average technology and waiting for my back-ordered webcam or glowing on webinars, I'm a certified financial planner and president of Sandine Strategies, a wealth management and financial planning firm. I'm also founder of Business Pros, the producer of today's webinar, titled Robots Don't Get COVID-19, Start Your Journey to Industrial Robotics Automation. We'll be featuring a panel of experts shown on your screen, who you'll meet in greater detail before their presentations. Business Pros is an alliance of business professionals collaborating to bring high quality educational content to entrepreneurs, business owners, and executives, as well as support each other's business development efforts. Here's how today's webinar will be structured. Each of our panelists will make 8-minute presentations. During these presentations, if you have a question, type it into the chat box. The chat function is displayed when you move your cursor over the Zoom screen and the icons down at the bottom. We'll answer those chat questions at the end of each presentation, and then open Q&A will occur after all presentations are completed. Lastly, a recording of this webinar will be emailed to everyone who's registered for the event. So if everyone's ready, let's go ahead and get started. Today's moderator is Kent Barner. Kent is technical advisor and self-described mercenary chief information officer, or CIO. CIOs are to technology as CFOs are to accounting. He started CIO Suite in 2017 after a 30-year career in corporate America as the chief investment officer or information officer. I'm going to unshare my screen now so we can get started.
Okay, welcome everyone. Today's topic is robots don't get COVID-19. You know, staffing the production line is a constant challenge for manufacturers, and COVID just intensified that challenge. So getting on your journey, if you're not already on it, to robotics can help with some of those challenges. We're talking a broader category is industrial automation. Some of you may have heard of Industry 4.0 or smart manufacturing. And these encompass many technologies converging IT and operational technology. In this webinar today, we're just going to explore the robotics aspect of that. And in the past, industrial robots have been used for high volume, highly repeatable operations. But as the technology advances and cost declines, options and opportunities to replace or augment human repetitive operations at medium and small size manufacturers are increasing. Robots help address many of the key challenges manufacturers face, including tight labor pools, absenteeism, safety, and global market competitiveness. Our panel includes robotic experts and manufacturing CEOs who will identify the advantages and disadvantages of implementing the different types of robots. They will provide insights into their journeys, and it is a marathon, not a sprint, so get started if you haven't already. And I'm going to keep this going pretty quickly. So our first panelist, Nick, if you want to share your first slide. Nick Armenta, he's an automation engineer with Olympus Controls. Nick joined Olympus Controls in 2012. Nick's works with companies varying from size from startup end users to billion-dollar OEMs to provide electromechanical automation solutions for everything from basic machine tending to advanced R&D. And of the 3 manufacturers that I personally know, 2 of them on this panel, Nick has worked with them all or is working with them all. So Nick is well versed to talk to us about his experience and share with us a little bit about robotics. So Nick, why don't you take it from here?
Thank you so much, Kim. Thank you for Business Pros for hosting me on this webinar. As Kit mentioned, local to the area. Some of these are my clients, so very familiar with the DFW locale. and the technology in general. So I'm with Olympus Controls. So just a quick intro, who is Olympus Controls? So we're a high-tech manufacturing distributor. But what that actually means is that we provide automation solutions. So that means that we're putting all the parts together. So we want to be the first ones you call when you have a problem. Here's a good example of something we've done. You see a robot arm on top of a mobile platform using vision systems, electromechanical grippers, HMIs. So pretty much the whole shebang when it comes to automation. And so why am I here? So we also take a very consultative approach. We work with some of the more cutting edge technologies, which means they're inherently not as well known and not as well understood. So our goal is to educate everybody so that they understand where these technologies fit and how they can help them excel and achieve what they haven't been able to achieve before in production and manufacturing. So the topic today that I'm covering is robots. So whether these are called 6 degrees of freedom arms, 6DoF, 6-axis articulated arms, they all basically mean the same things. It's a machine that can basically duplicate anything that your human arm does. We can reach any point in space from any location. So why is that important? That's because of the implications. Eventually, they will be able to do everything you can, but faster, stronger, with more precision, and for pretty much infinite durations. So that's extremely exciting. It's pretty much the closest we've got to an everything machine since we've started. So you'll see here, it's more of a humanoid type of arm, but at the same time, it has all of the mechanisms that we'll be talking about here today. It's really as close as we've gotten to being able to do everything with one type of device. But of course, that wasn't always the case. These robots have evolved from very simple mechanisms, as you see here, to the more advanced, which I'll show you right now. So let's go with a brief history. So the first agreed upon robotic arm was the Unimate, developed for GE for welding. So this was for spot welding. It did the same thing at the same spot over and over and over. From here, we got to the Stanford arm, which is the first electrically powered and programmable arm. So from here, we've advanced to something that can be changed and is controlled completely with electricity, which gives a lot more capabilities. Then next step is 1963, the first 6 degrees of freedom. So this is what I mentioned earlier, something that can manipulate the things the same way your human arm would. We move on to the silver arm in 1974. This was a device that integrated pressure and touch sensors. So instead of being hard programmed, it is now able to sense its environment to make decisions on the fly and be more accurate and more flexible. In 1981, we started putting the motors on the ends of the arms so that each joint could be controlled independently, not an overall cam type system. What this allowed was for even more complex motion and even lighter weight, stronger arms. In this next video, you'll see we sent robots to space in 1997. So now we're putting robots in very harsh environments with very complex applications. On the next, we have the Da Vinci. So this is very exciting because this is the first robot that was actually able to be approved by the government for working not only around, but inside of people. That's a pretty big step for us trusting robotics, so a pretty exciting step as well. This next, in 2007, Universal Robots created the first robot capable of working alongside humans. So now you can safely install robots. You can see me in this video controlling it by hand, something you really weren't able to do before the mid-2000s. In 2012, a company called Rethink Robotics created the Sawyer robot, where they integrated cameras into the end of every end of the robot. So not only can it touch, but it can also see everything it's doing, which is a critically important step if you need to make on-the-fly decisions. And then in 2018, Universal Robots started integrating those touch sensors into every single one of the robots. So every robot that goes out has a sense of touch from the E-series. So it can understand if it's encountering forces or if it's being impeded by objects for even more safety. So the two different flavors of robots we have typically today, we separate them into traditional industrial and collaborative. So traditional industrial is what you'll see here on the right. These are large arms, almost like a T-Rex or dinosaur. They're going to be very fast, very heavy, very efficient, very strong, very accurate, and made for very specialized environments like welding. What that also means, though, is that you have to put them in these enclosures or custom-built cells. And you'll see the fence in the back there. There's quite a bit of space involved when you're deploying these robots. So it's not something that anyone can just do on their manufacturing floor. They also come with a very steep learning curve. So anyone that's programmed a robot about 20 years ago can probably still program them today when it comes to these types of robots. The programming styles are tried and true, but they're not necessarily intuitive for the new users of today. They're primarily used automotive, very high volume or high production lines, whether it's palletizing, picking, machine tending, or welding adhesives, all the different types are where you'll find these robots. The next flavor is a collaborative robot. So these are a little bit different because they are able to be deployed alongside people, as I mentioned, and you'll actually see they have lower payload capacities. So we're only dealing with less than 30 pounds typically, but we also have slower speeds and we have a shorter reach. So those all sound like bad things. And I thought the same thing when I first found this technology. But in reality, they're actually able to be a lot more flexible. So that same slow allows them to work alongside people. The ability to move them around makes them very easy to redeploy. In this video, you'll see them wheeling around the facility. And I know for a fact that Gary moves his robots around as well. So excited to talk about that. Then they're very plug and play with standardized hardware options. So now instead of having to look for a dispensing solution, a gripping solution, welding, palletizing, they have off-the-shelf products that you can be very confident will integrate seamlessly with your production. So you don't have to reinvent the wheel each time. But for all robots, the same is true. So these robots are at their core a tool for enabling you to have more competitive advantages in your production. So they're going to allow you to have a better use of human capital, having people use their minds, the most valuable asset, instead of their hands. Picking up and putting down things is not a very mentally strenuous effort. They'll allow for higher throughput, so they're capable of 24/7 operation, which means they can work all the time without any kind of person monitoring them, overnight shifts, 3 shifts, 2 shifts. They have higher quality, so once they're programmed, they do this exact same job each time, so you can lock in the amount of quality that they offer. And they also have a more consistent process, which goes back to quality because they make the same type of parts, but also essentially puts your production line on a clock. The robots have the exact same cycle rate, so that you can expect the parts are going to come out to this basically millisecond every time the robot runs, which really helps you track your production. And then here's a quick list. We'll show this afterward. There's quite a bit to touch on here, but the core basically says if you have high volume, low mix with a high throughput needed, you need an industrial robot. If you need something you can quickly redeploy and something you can program easily and own yourself, you'd want to look at a collaborative robot. And then here from a financial perspective, so I just put together a quick simulated case study showing the ROI based on a cobot and an industrial robot. So on the bottom line, you'll see the cobot graph. So say 1 quarter in, you're investing about $6,000. 3 months is about what we see for implementing collaborative robots. So you're immediately starting to generate an increase in a return on that robot. Whereas with a more traditional industrial robot, it's going to be closer to 6 to 9 months when you're deploying that. So you're starting a little bit lower and you're not producing as quickly as you would with a cobot. From here, you can see that trajectory goes a little bit higher incline because we're replacing more workers than we would with a cobot, but we've actually already made a return on our investment 1 year later with a cobot. If we talk about retooling it, that's considerably more expensive and more of a time commitment with an industrial robot, which you'll notice that drop off here. Whereas with the collaborative robot, you can actually do retooling pretty cheaply and effectively and keep your ROI in the black. That is basically it. I'll be answering much more questions, but we'll move on here. Again, this is my contact info, and thank you, Kent and Business Pros, for hosting me.
Good timing. I've asked, we had 10 or 12 minutes a person and we needed to compress it down to about 8 minutes. So nice job. Okay, next up. So Daryl, if you could start to cue your slides, there you go. And I believe you're unmuted. So Daryl Paul, Marketing Manager of Omron Industrial Automation. So Daryl is an engineer who spent his 20+ years of sales and marketing career specializing in manufacturing automation with advanced motion control and robotics. The other thing about Omron, and I think I have permission to say this. If not, we can edit this out. But Omron's building a factory here in the DFW area, and they're going to have a great showroom for robotics after that's complete. So we look forward to seeing that. Daryl, take it away.
Yes, thank you. So we're going to have an operations center in Dallas. It won't be a production factory, just to have a clarification there. But the services for our customers, proof of concept centers, and how we're supporting our products in the Americas is going to be part of that operation. So we look forward to being part of the Dallas marketplace, and we have proof of concept centers actually in all the corners of North America. So especially when it comes to our robot business, because this is a business that you really need to get involved with the customer's operations and truly understand how you're going to accomplish your application. So I am going to talk fast and kind of move fast here to keep us on time. But just a quick background on Omron. We have 80 plus years. We were founded in 1933, $8 billion in annual sales. We're located in 110 countries. We're primarily focused on industrial automation from a global discrete machine control automation, not getting into all kinds of process industries. We are the global leader once you aggregate all the business globally. So pertinent to today's discussion, okay, is Omron offers collaborative articulated mobile robots. We also offer high-speed articulated Scara and Delta robots. And the other thing here is, regardless of your application, there's always going to be automation that has to go with that robot in order to be able to complete your system. So Omron has an offering of the overall machine controls, motion control drives, safety controls, safety devices, vision, HMIs, and data systems. So regardless of where you're starting, whether it's a single collaborative robot that you'll see in the slides doing machine tending, or even a single high-speed robot that might be doing part feeding. Wherever you're starting your journey, we're a good company to work with to kind of go from that single project and scale up to where you want to go in your manufacturing process. And when we're looking at today where robots are, because it has evolved, robots are integrating into every part of the automation industry. And so kind of a good way to look at this is not just about the fact that it's a robot, but it's part of the manufacturing process. So the first thing that we kind of are looking at today is what's called collaborative manufacturing. And this involves robots that are mobile, that are collaborative, and robots that are armed, similar to the ones that Nick was talking about, and how they can be directly coupled with your operators to really bring a new level of productivity. The next is autonomous manufacturing. This is where those high-speed robots that Nick was showing, those are becoming more tightly integrated with the actual machines and manufacturing lines to really advance to the next production levels in our global marketplace and deal with more complex production needs and flexibility. And last on, we'll real quickly touch how artificial intelligence is starting to integrate into the robotics market and how that's going to actually affect the journey for customers. So in collaborative manufacturing, one of the first areas that Omron sought to deploy the technology, because we started selling this last year, is that we deployed it in our own factory. And one of the areas that we focused on was material transport, which we were able to automate 75% of that material transport and reduce the lead time of that transport material 80% to the production lines. And these production lines were all high mix, low volume, very configurable orders. So we basically benefited greatly from putting these collaborative robots into different operations. As you can see, you're seeing a lot of different things being done by these collaborative robots, by the mobile robots. So altogether, it's a very, very flexible technology that is really changing our manufacturing place today. Similar to what Nick did on the value propositions, we're reducing the non-value add labor and we're increasing the value add labor. We're increasing the manufacturing flexibility and we're adding quality and traceability to the process. All right, so then let's see, then go to the next slide here. So one of the areas here is, and Nick touched on this too, is the return on investment. And really that journey that Nick outlined was a great way to look at it. And for collaborative robots, there's things that differentiate it from the high-speed robots today in the fact that there's a lower cost of integration, lower cost of ownership, the ease of programmability, the fact that you can literally teach these robots. And as you can see, these robots can also directly interface with other machines without control interfaces. This reduces a whole lot of cost and a whole lot of speed to implementation. And so these robots really become a true collaborative partner to your operators. So Then we're going to move on to autonomous robot manufacturing. And here we're kind of showing you the success story about one of our customers called TP, and they had a goal to fully automate their production. They were able to achieve really an astounding 9x production increase. And so can't promise that's going to be in every case. But what this is the high-speed robots are really becoming very tightly integrated with your automation machines. And what was able to be accomplished here is the speed of their production, the flexibility, the intelligence. They were actually able to change what they were packing, what they were manufacturing, how they were executing orders, all in real time. The production line and the robots were autonomous in being able to do all those changes on the fly, all at the same time tracking quality and tracing the products through the process. So in this video here, you're seeing a lot of our high-speed robots. You're seeing a couple applications of our mobile robots. And really, this customer was able to pull those technologies together to really kind of give it that full autonomous or complete end-to-end automation capability. The next here is to touch on artificial intelligence and how that's going to be integrated or is already being integrated into robotics. So we've done a couple proof of concepts, and we also have a couple customer success stories to share. And what artificial intelligence is being deployed in terms of automation is we deploy at the edge level, because there are artificial intelligence systems that are deployed at what's called the cloud level, which is up in the servers and IT market. And then there's edge level, which is down at the machine floor level. And we process artificial intelligence in real time to affect the process optimization and real-time adjustments. So SKF was able to use this technology in their ball bearing manufacturing process, where they could actually detect things that couldn't be detected either by automation machines or even by humans in terms of burn marks and stains, and then be able to understand what changes in the process needed to be optimized in order to then eliminate or correct those quality problems. So it was really just a completely new level of manufacturing that's opened up for them. On Norva Nordisk, they had the implementation where they wanted AI to help them optimize their production operations to understand, given certain demands of manufacturing and different products, what was going to be the realistic manufacturing capability and optimization schedule. So those are two different implementations of how artificial intelligence is being implemented today. The next one here is where artificial intelligence is learning from an operator. In this situation here, there's a vision camera in several different spots of this machine. It's watching what the operator is doing, and the robot is learning how to assemble and build certain orders based on watching the operator. Then, as the artificial intelligence system has learned several operations, it then can also teach operators what it's learned in the fact that things could be optimized by doing it this way or that way. So there's a true exchange of information between the artificial intelligence system and the human operators to really optimize production. So I know that was real quick, and I look forward to talking to you guys in our discussion section, but that's all for me.
All right, fantastic. Thank you, Daryl. So our two vendors on the line have showed you kind of a range of robots, a history of robots, and now let's talk to some folks that have actually started their journey or are well on the path way down the line. So first off, Mark, I'm going to unmute. Okay, you're unmuted. I'm going to share your slides. Okay, let me get that started. So Mark King, Chairman and CEO of Micropack Industries, a publicly traded company, OTC symbol MPAD. Mark has 30 plus years of senior management experience in design development, manufacturing, and business development serving the advanced electronics industry. His business experience includes an emphasis on strategic development, business process improvements, and business growth. Mark is a certified NACD Board Leadership Fellow and recently achieved the NACD Board Certification status. Mark, take it away.
Okay, thank you. I'll let you go ahead and adjust the slides for me.
Yeah, Kent,
All
why don't you go to a slideshow? Right now, we don't see the slideshow.
Okay. Hang on just a second.
So on this first slide, I just wanted to express that I do not make robots, and I am on a journey to integrate and initiate programs where we're going to automation and robotics along with data analytics. And so I thought I'd share with you a CEO's perspective that I'm going through on developing a roadmap to get to our future state and help you maybe think through some of the questions that come up with that. So
I'm sorry, let me get this figured out.
I think if you hit play from start, it'll work up at the top.
Yeah, but it's not showing the presenter. It's in presenter mode, so I can't. I apologize. We're just going to have to go through from here, I believe, is going to be our best.
that's fine. Yeah, that's
Okay.
fine. I can, if you can get it up. Can you get it
Yeah,
up?
let me get it going. All right, there you go.
Okay, so that's kind of who we are. We're a high mix, very high rel business. We do a lot of work with NASA. We do a lot of work with the Department of Defense and in the medical community. Go ahead to the next slide, please. I wanted to show this slide, and I think Paul Mayer is on the line, and Rick from the Garland Chamber. Paul's the CEO of the Garland Chamber. We work this through to kind of communicate through the Dallas County Manufacturing Association and the leaders of the manufacturing companies in Garland area. Where are we on the roadmap? And if you look at this in terms of data analytics and robotics, and I want to express the fact that I combine the robotics with data analytics because they kind of go hand in hand. To the far left is the very manual, old-fashioned fabrication facility, and to the right is the extreme industrial 4.0, completely lights out AI factory. And so what I want you to remember here as you go through your journey or enter into that journey, ask yourself the simple question of where are you today on these roadmaps, on this roadmap, and then where do you want to be in your future state? Define your future state, say in 3 years, and then you can start to initiate plans to get you along the path of the initiatives that will take to get you there. The stars represent pretty much where I am right now. If I go back 5 years, you know, it's much further to the left, to the top, and the data analytics. You start with, of course, all of us with the ERP, but how do you use the ERP and the data and convert that into information is critical. And then how do you use AI? Because AI is here to stay. It's been in development for 30 years, but right now AI is available to us as a tool and a technology that was not otherwise available to us several years back. Go ahead to the next slide. So I just wanted to show an example of what we've done at MicroPack. This is a particular product. It's used for the launchers for the Patriot system. The importance here is that it has an opto separated connection or controls to turn on and off MOSFETs. And this particular part that you see is about the size of your thumbnail. And to the left is when we were doing this by hand without any automation. You will see the numbers of opportunities for failures, the throughput, the cost, we were doing about 12,000 a year, which was our capacity. If you go to the right, you'll see that through automation and process optimization that goes with it, we were able to increase our throughput from 12,000 a year to 75,000 a year, and of course improve our costs. Now, we improved our costs by redesigning it such that it was suitable for, because we had to redesign it because it was suitable for automation. So the robots you see there are automated, what would be referred to as autonomous robots that are used in order to do what we used to do manually. So we're really excited about the opportunities that we're bringing into play, both with the quality impact, the cost impact, and of course, more profits and throughput, which is what we're looking for. I think it was Nick that talked about these machines are very predictable on the time and cycle time that it takes in order to perform an operation, which allows you to optimize through lean initiatives, flow and throughput, so you don't have the variability that you would have. And so finding your bottlenecks becomes easier as well. Go ahead to the next slide. So I just wanted to introduce a concept of looking at a value stream inside of a manufacturing company. And in this case, what I want you to think about as you go on your journey is where in the value stream does it make sense for both data analytics and automation. And that's all the purpose of this. 3D printing in the front end has been very valuable in terms of proving out designs and communicating to customers' requirements. In the fabrication line, it's starting to enter into, particularly in handling fixtures for us, tooling, things of that nature. We're seeing robotic applications and have projects ongoing, both in the fabrication area and in test. And I just bought a real nice piece of automated equipment to do inspection on material. And material handling's already been discussed. Material handling is probably the most, between material handling and shipping and packing, those are early adopters of the robotic technology. So that's an opportunity, low-hanging fruit that you can do. And what we're trying to do here is eliminate the mundane, repeatable operations that a human would do and elevate that to be performed by robotics in collaborative formats. Go ahead. So my last slide, and I know we're short on time, so I'm really anxious to answer questions. But you ought to ask yourself why you should consider automation, and in parallel with that, why you should consider data analytics. And I put on the left, obviously a return on investment exists, particularly as Nick pointed out with the cobots. But also what you get with it, which sometimes we don't consider, is improved quality, just because of the consistent repeatability and the quality enhancements, as I explained earlier in my example. It moves the workforce up the ladder, and that's really important because it allows you to pay your employees more. They're doing more value to the process, and it helps to eliminate the non-value repeatable processes, of which, from a healthcare and a carpal tunnel and some of the problems that people have with repeated motion, it really eliminates that problem. I mentioned lean principles already in ergonomics. And I just like to say that, what I'm excited about is a lot of the data analytics, a lot of the AI that we're talking about has finally arrived. And I've been in technology for a long time, and it's nice to see that it's finally arrived. Same thing with data analytics that goes with this. The whole mission here is to convert data into information. And but you need to understand that you have the ability to reduce your overhead cost and reduce your inventory and manage your inventory in a much more efficient way, which of course increases your cash flow when you're running a business. So I think that if you coordinate, work, collaborate together, we can really move the needle, and that's what I'm excited about. I'm not to the end state. My future state is still in the future, but I have a lot of experience of thinking through what it's going to take for us to move this needle and consider the future state and the roadmap to get there. With that, I'll turn it back over to Ken. Go ahead and turn it back over.
All right, thanks, Mark. And so next up is Gary Kuzman. Let me see how your slides are going to perform for us today. Is that the slide deck? Can y'all see that? No? Yes, no, anybody? No? Okay.
It's your
No.
desktop right now, yeah.
Okay. Well, it goes into presenter mode and I lose it. So we're going to have to just do the same thing in the interest of time. How about that?
Okay.
See, yep.
Yeah, we can see that.
Okay.
You might want to make it a full screen. And I'm not sure the automation is going to work either.
This one doesn't have any.
Oh, okay, good.
All right, sorry guys. Gary Kuzman, President and CEO, All Access Machining, and a privately held company. So I'd be interested to hear some differences when we get into discussion between the drivers of a publicly held organization versus that of a privately held organization. Gary is the President and CEO of All Access Machining, All Access Robotics, and ACT Sheet Metal and Fabrication. His 40 years of manufacturing experience has led to 7 U.S. utility patents being issued for his inventions. His entrepreneurship leadership has resulted in the organic creation of 5 companies. His latest company, All Access Robotics, has been written up in the New York Times, Boston Globe, Fortune magazine, and other business publications as an emerging leader in the robotics integration market for manufacturing companies and unattended operations. So, Gary, take it away. Is he on mute? There you go.
Ken,
Yes.
can you click on slide 1? There you go. Great.
All right.
Okay. So this particular slide that you see right here is, let me give you a background on the companies that I've started up in the past. They've always been started up with the latest available technology that's in the manufacturing environment, or mostly around metal fabrication. All Access Machining was started about 10 years ago, 13 years ago, and that company moved away from the traditional 3-axis machines, and we started up immediately with 5 and 11-axis machines, because at that point we were looking to create one part in one cycle, and that could be done with 5-axis machines, where when you had 3-axis machines, you would have to have multiple setups to create parts. The goal was obviously better quality and a faster throughput on the machines. The ACT Sheet Metal is a metal fabrication company that's really involved in a lot of metal welding assemblies that are put together, and again, we have a variety of industries. And in the middle, sandwiched right between, and it's really now going to be bridging both of those companies, is All Access Robotics. All Access Robotics was started about 2.5 years ago as a result of the automation that was put into both All Access Machining and ACT Sheet Metal. And it turned out that our engineers were so good at this particular process that we created All Access Robotics, which was really designed to help other machine shops, other manufacturing operations with the automation and implementation of automation within their own factories. So we took the knowledge that we learned from doing our own integrations and the problems that were associated with low volume, high mix operations, and we would pass that along by helping other companies take advantage of the newest technology out there, which is really these collaborative robots, which have been talked about by Nick and several other the presenters. In the next slide, the very first thing that I really want to talk about, and I think everybody else has, that automation is, at the end of the day, from my perspective of a CEO, it's a journey. It doesn't stop. And you build upon what you learned the last 6 months and the 6 months before that. And it was really, just to kind of give you a perspective on this, is we started off with machine tending as the very basic thing that we wanted to achieve. And why did we want to do the machine tending? Because that was where we saw the greatest value in the operations. Where we only had a 1-shift operation, we then moved to a 2nd shift operation, and then finally we moved to a 3rd operation with very few people, but we gained 66% more manufacturing time by just adding the robots onto the machines. Interestingly enough, today with this whole COVID thing, we were actually ahead of the game even before this became a problem. Well, as COVID became a bigger problem, we were well situated to take advantage of the automation that we already put in. And for instance, pretty much today, the way that we look like is on first shift, where we have the bulk of our employees, is they are the ones that are doing the automation and the development of the programming of the robots, setting the machines up, qualifying the machines. Second shift looks with just a few staff employees on the company that are running 5 or 6 machines and letting the robots go. And when these guys go home at night, we have actually no operators, and the robots are running lights out all throughout the third shift. And because of this whole COVID thing, we are now able to actually add a weekend shift, which also has a very minimal staff that allows for the changing of tools on each of the machines. That now we've picked up about 50 to 60% more time. And when Mark was talking about productivity improvement, this is a huge productivity improvement without having to add any more capital equipment other than the robots. We don't have to go buy more machines or expand our workforce or the real estate on our floor. So going back to this, the journey part of this whole thing, we started off with the machine tending. Then we found out that we got good at that. That's all taken care of. Then we moved the needle on that to automate some of our other laborious processes like laser marking. And then we got a little bit more ambitious, and several of the presenters have talked about this, is we actually had in-house artificial intelligence development, where we've been moved that into the inspection cycles, where we can actually put cameras on the end of the robot using artificial intelligence. It will actually pick up what I call non-uniform defects. It'll look for any type of defects in the products. It'll look for missing hardware. So this is a way that we've been on this continuous journey, adding in artificial intelligence for a really labor-intensive process, which is inspection. So when we went out, and that's our particular journey right there. Our goals and objectives are summarized there below. I've talked about many of those things. And at the end of the day, from a CEO perspective, it's always about improving your margins and your quality. Just remember, the robots are only going to give you better quality as long as you have a proven process. If you're buying the robot, a lot of times people come to us and they think the robot's going to improve their quality. It's not going to improve. It will improve your consistency, but if the process isn't good, it's not going to help. So that was pretty much how we approach this whole thing. And then there's the next few slides. On slide number 3 right here, this actually shows 3 of our machines here. One of them is a multi-11 axis mill turn machine on the far right. You can see the robot in front of that machine. In the background of that thing, you can see 2 other robots machine tending a couple of other 5-axis machines. Perfect, Kent. Next slide. This is just a close-up of how we implemented the robots. This happens to be picking parts up manually and adding them into one spindle, and then it'll pick it off the other ones. And you can see the parts that are just sitting on the parts presentation tray. The next slide shows how we use the robots in our sanding and deburring operations. So that's been all set up. And again, we have customers that don't like to have machine marks on the parts that we ship to them, and so we just have to sand them out. And again, this is actually, as even Mark mentioned, this is another health and safety benefit of the robots, where the operators are not exposed to either any dust that's around there, and our operators don't have any muscle fatigue, at that point. In the next slide, one of the other, again, health and safety involved once we move it to automated inspections, whether it's an end-of-arm camera or actually integrating into another vendor's inspection system. Health and safety-wise, it helps to improve the fatigue, what I call inspection fatigue, by the operator. robots will not miss. If you train it correctly, it's not going to miss the defect where the operators can get tired. So this is an automated inspection process. I think the final slide that I have actually shows one of the brake presses that has a robot that was designed to put parts into a brake press and remove it afterwards. So Kent, that's been pretty much our journey, and again, we continue to add things all the time.
All right, fantastic. And while I've got this up, we're about to just open it up for panel discussion, and please submit any questions you have into chat. That will be helpful for us. But one of the things, you know, and Mark, you weigh in on this as well. We're looking at Gary's place. But, you know, there is the robot, right? And you go buy that robot, Nick, you could tell me, you know, 30,000, 50,000, somewhere in that neighborhood. But then what else did you have to do here, Gary, to make this work?
So, yeah, there's a lot of things that you have to make it work, and I'll try to point them out. You've got to build a parts presentation tray because parts have to be loaded into the machine tending environment. But to do that, that robot has to be in a fixed point in space that cannot deviate. Otherwise, it will not be able to load the parts in properly. So we came up with another set of parts that are in for patents right now that actually, without drilling holes into the floor, we actually can lock that whole presentation tray right in front of the machine. So whether it gets bumped or not, it doesn't move, which is something you got to worry about in a factory environment. You have to come up with grippers that are on there. We also have 3D printers that we make special fingers that go into there. So there's probably at least another $20,000 to $30,000 worth of effort that has to be put in to make these things what I call robust, you know, for the operations. Nick, I don't know if you want to add anything else to that.
Well, yeah, this is Mark. Just to elaborate what Gary said, you know, what we'd like to hear is how many zeros are on these numbers. You know, 10 years ago, it was 300,000, now it's 30. So, you know, that's the amazing thing is that we can now implement some of the robotics that we've been dreaming about in a very affordable, with very affordable equations.
Yeah, just to add on what Gary was saying too, he's exactly right. And in this application, he's touching on here is what we refer to as a pick and place. So a common mistake I see being made is, like Gary mentioned, really refining your process and having a very straightforward parts come in on tray, parts go into machine, parts come out of machine. That's a fairly simple process that you can nail down quickly so that you can automate it effectively. And we see starting simple with something like this is really the key. Because like Gary mentioned, I don't think he realized all those pieces were a part of it initially. I didn't realize all those pieces were a part. So the more you learn their simplicity, like you said, marathon, not sprint, that's really how you can become most effective. But no, Gary nailed it. All those pieces there, robots, automation in general expects consistency. If it does not see consistency, it does not produce consistency.
One of the questions that I got, I don't know if the rest of you got it, but it's a very valid question. You know, are we talking about using robots to replace people and replace jobs, and what happens to the job market as a result? You know, some people get sensitive about that. And, you know, the real truth is, at least in my company, this is Micropack, you know, I have a lot of people that I might pay at a lower pay scale to do a lot of repeated jobs. When I can replace that, I can elevate their pay. I can elevate their skill levels, not just in the electronics, programming, software side of it, but also in the work that needs to be done. And so they're adding more value to the process flow as I build product. And what that means to me is that I'm able to pay them more. And so instead of the old days of paying somebody, say, $11 to $12 an hour to do a very entry-level repeatable work, I can pay them $15 to $16 an hour to add, and they're worth it because they're adding value. They're 8 hours a day they're spending or whatever is adding value to the process and the flow. And so it's very important to me, and in terms of the people side of this, that we implement that in a way that's good for all of the employees. And by the way, the employees get really excited about what they can do with automation and robotics. At least that's been my experience.
Yeah, let me add a little bit with Mark. I think when we first brought the robots into our company, I think people were a little bit tenuous about what's going to happen to my job, and I think that's always a natural consequence. But as they realized that, some of our employees realized it was to their health benefit. They realized that they didn't have to sit there with their muscles and really do rigorous manual labor that could be transferred over to a robot. And I think some of our employees appreciated that. And as Mark said in one of his presentations, they're moving up the ladder. All of our employees we've sent to training schools, and we teach them how to program the robots. And I think Cheryl put a comment about, well, what are the future jobs? Well, the future jobs is companies that put in the automation now puts their employees at an advantage for the future. And when I say that, they're learning how to actually use this technology where maybe my career, I have 20 years left in it, but somebody at 25 years has about 45 years left. And so the employee that is at a factory that employs automation is going to learn those skills that is going to take them through numerous companies in the future.
Great. And then, there's been questions, and you both answer those as to, kind of how do we, affect the employees. But, one of the things I'm having a challenge with is and I mentioned this at the beginning, you have operational technology and you have traditional information technology, and these are converging these things. So have you seen any education or any programs or any curriculums that try and bridge the two of those? Because historically there's kind of a divide there. And as we get into AI and machine learning and some of these other things, we start to cross over into what I would call traditional IT. I'd be curious if, from a staffing standpoint, have you done anything special in that regard, or have you seen anything that helps in that area? That's for Mark and Gary.
I just real briefly, what I've done is I've expanded my process engineering group, and I've taken operators that have adapted to the robotic and automation that we have, and now use them in an engineering sense. And there's a lot of self-pride that gets developed there. So yes, there's a career path that exists that you can develop for taking people that are typically working on the line, and then can move towards working the processes and the improvements that you put in place. And there's a connection here.
Great.
And I think I would just add to that is I think you look for the people on your line that have the inherent interest who want to work with the automation. And once you identify these people, spend more time with them and give them the training that they need, whether it's in-house or you outsource that training to the manufacturers of the robot. One other point I want to bring up, somebody talked about, again from Cheryl, about with unemployment rising, are we concerned about taking positions? I was actually asked that question a few days ago by a reporter from Reuters, Reuters news service. And I said, this is a very interesting point. If you take a look of all the jobs that are in the United States, manufacturing probably represents less than 10% of all the entire employment. Most of the unemployment, Kent, you brought this up from the very beginning in this times of COVID. A lot of the unemployment that we're seeing is in the service industries that are out there right now. And I think by employing the robots in the manufacturing, you're still going to retain a skilled workforce, because as Mark so aptly put it, it's doing the repeatable jobs that are out there that are low value, that have non-value associated with them. I think those were your words, Mark. And so the robots in the manufacturing are not going to replace jobs in the manufacturing. They're only going to be supplementing what you have, and they're going to be able to improve your throughput. So, Cheryl, I hope that answers your question.
So, Daryl, I think somebody directly asked you a question about global competitiveness. You want to talk to that?
Yes, so we do get a lot of these questions as well. We talk about that with some of our executive team meetings. And whether you're a small company or a large global company, this is a common question. And what we see the robot impact is it level sets not just America or Canada or North American operations. They're able to level set and become globally competitive where before they might have been regionally competitive. And then also larger companies who have multiple sites of production and are having a hard time balancing the costs of those operations in different sites and being profitable globally. Automation allows them to level set those operations as well, where they can have operations in multiple parts of the country that are standardized or the globe, and they're achieving their financial goals as well. So I think robots is a great way to address this global competitiveness and global operation challenges as well.
Great. Hey, Nick, you had a slide we couldn't include that kind of talked about some of the gotchas and how to be prudent about marching down this path. Do you recall what I'm talking about, and can you elaborate on that if I'm not putting you on the spot too much?
Yeah, definitely. And Gary, please chime in because I touched on some of those points too. So it starts out when you're investigating automation. Kind of what Gary touched upon before was that a lot of people just aren't ready for it. Either it's their process isn't made for it, or they don't have the workforce that can implement or support it. So I think step one is understand what you need to deploy automation. So that's just making consistency key, making sure parts are the same spot every single time, being assembled the same way every time. That's when you can start looking into automation. So step one, definitely. Gary, if you have anything to add on to that, I think that's the most important part, is understanding where automation can be effectively deployed and making sure that you are in a position to do that. Was that your experience too, Gary?
Well, this is part of the journey. You learn from the mistakes, and you learn what the repeatability that you have to have with how you present the parts to the robot so it can load it into the machine. It's all about consistency and knowing where the parts are. So, but again, that's part of the journey. Once you figure out what the mistake is, you move on. In our process, okay, we loaded the parts, but then we found we had metal shavings that would fall onto the into the vise that held the parts. So then they would have to be blown out. Then we found out what we learned is this: the operator would do certain things that were just instinctive to him to do. But when you put the robot in for the first time, you don't realize everything that the operator is doing instinctively, and the robot has to be trained to do that. And that's why people will never be removed from the process, because they're always in a process of continuing to teach the robot all these nuances that people have done. So that's why I think what you're talking about, Nick, right?
Yeah, those are great examples of the kind of gotchas. I always mention the unknown unknowns. And when we're starting with automation, there's going to be some things that come up that no one really expected, just like Gary mentioned too. And I think that's why part of it too is starting very simple. So even if it's not an application that's going to generate a massive ROI, just the experience of understanding what those unknowns are and just eliminating the risk by going with all this material for a very expensive, complex application is also key. So it's going to allow you to iterate faster at lower cost and really understand how you can be most effective with this tool. So building in consistency to your process, starting very simple, treating it as a tool. Those are two ways that you can set yourself up for success.
Right. So we're gliding into the end of the hour. Who had the question?
I just wanted to mention something, Ken. Yeah, that we are coming up on 12:30. But we're going to let this conversation run. Attendees, if you can stay with it, please do. Otherwise, if you have to drop off, thanks for attending. But let's just keep this discussion going. It's a good one.
So, Mark, I've got a question for you. As a public company CEO, you know, one day you went to your board and said, "Hey, we're going to start doing robotics." I don't know. I'd be curious how that conversation went and what kind of pushback you may have gotten or support one way or the other.
I'm chairman of the board as well, so it was an easy decision. But I think that resistance is not. I don't worry about resistance at the governance and board level. It's more at the operator level, and culture hasn't been discussed and probably needs to be.
Yeah.
When you get ownership with the people that are doing the work, and you focus on KPIs and objectives, and what you're giving them is a tool set that they can achieve better goals, better objectives. It's much like, we give a laptop computer to a production planner, so that production planner can do and have the tools that they need. And on the line, and the supervisors that we work with, we're giving them robotics as a tool to enhance their throughput and their performance. So they see it as a collaborative support function. And like I say, we're able to pay the people more. Once we have ownership at that level, taking it to the governance, it's a real easy decision to make, to implement for a lot of reasons: productivity, customer satisfaction, all the things that have to come to running a strong and good business. So, yeah, it wasn't a difficult decision. And one of the things that Nick pointed out is, if it cost me $250,000, I'd probably get some resistance. I might even resist it myself. But when that cost me $25,000 just for the machine, then it becomes something that is very doable, and it's very scalable. And scalable and culture are the two words I'd like you to kind of hold on to, because you have to collaborate and integrate those two to make it work.
Yeah, I'd like to reinforce one of the words that you're using is ownership. And we've seen this time and time again in customers, is talking to an operator and doing a success story, and we're doing our video shoots and we're doing interviews. What ends up happening here is before, the operator is completely consumed with the physical action of completing the production. And now that they're working with a robotic system that is essentially running that line, they're moving their role, instead of just showing up to work to be a operator, to being an owner, to being a production line owner or a cell owner, where they're walking around that machine, making sure that things are supplied. What's the next order? Is there quality happening? They're going around and really more or less using their minds, and they're taking ownership over that particular section of manufacturing that's contributing to the company. So it really does help make a culture of ownership in manufacturing. That's what I've been able to observe. So.
Yeah, good for you, Dale. I wanted to. I think it's Cheryl Harden asked the question, and hopefully Cheryl is on. A very good question that she asked, and that is, how do you get started? Should you do an operational audit or what? And it kind of gets back to my value stream chart. You kind of start with that, and then you do a process flow. In manufacturing, we all hopefully have our processes well documented and understood and qualified. And that's step one. Once you have that, then you can look at what is the mood or the waste, the operational aspects that you really would be able to replace with a robot to enhance the throughput and the efficiencies and the quality defects, things of that nature, by looking at robotics. So it is a mapping of the process, and it's an understanding of the process that you're doing and understanding where it makes sense to start. And I really agree with what Nick said. You know what? I would not try to just do it by ROI as much as introducing it as a culture inside your company. Once you get there and it starts and you get ownership, it's a really great thing when it starts to take off.
Fantastic.
Thank you for that question, Cheryl.
So anyone else have any further questions for the panelists?
If you go back up to the top of the chat, there's a question from Jeff Cartwright. He asks, do you find that you have to improve? Gary, you talked about the fact that robots don't improve quality. Do you find that you have to improve incoming materials, the quality of incoming materials, in order to make the robots work properly? Is there a standard that's upheld there where that has to change?
I think with that particular one, that should be something that should even be done before you consider putting robots in. If you don't have a robust process to begin with, a robot is not going to improve it. And so if you have a process problem, that should be something you look at automatically if you got an incoming materials problems. But from our standpoint, we've had to tweak some things in our own implementation. Maybe we add a little bit more sacrificial material onto the parts, so that we have a greater latitude when the robot, drops it into the vise. But that wasn't really an issue for us of improving that. I think it was just always getting a consistent placement of the materials.
And I'll
this is Mark.
Go ahead, Mark.
Yeah, I was going to say what I recently invested $60,000 into an incoming inspection machine that is it's an amazing machine because it allows you to measure within great accuracy automatically the tolerancing that you need on. And for me, it was these small circuit boards that goes into a medical application that has to be inserted into a plastic housing. And if the boards were out, plus on the plus side out of tolerance, or even within tolerance, but on the plus side, and the housings were on the negative side, the boards just wouldn't fit. And so by understanding the statistics and understanding the measurements that we need, we've automated that entire process. And it takes 60 seconds for it to process, but the amount of time it takes to do it, it can't really be done by a human, even with mics or other methods. It's all done under a microscope. So automation of the key parameters that you want to measure in your supply, from your supply chain, to me is critical, because that's where the dollar signs are smaller. Once you get bad material into your line, whatever that is, for whatever reason, the dollar signs get big quick. And so incoming inspection is a process that you need to optimize in a manufacturing company, and then you can use automation in a very positive way to enhance that. And talk about return on investment. You get bad material on your production line, you are in trouble. You're building scrap. You're spending engineering and process engineering time to try to figure out what happened and try to fix it. You got customers that aren't happy because you're not making deliveries. There's a lot of return that you get by automating your processes for incoming material.
Fantastic.
Just to give you a little bit about how this equates into a project, there's a very high trend towards the integration of machine vision on robots. So in terms of a project, even at a low collaborative robot project that, let's say it's going to cost you $30,000 for the robot, $30,000 for basically your cost of integration, it's only costs somewhere around $2,000 to add on a machine vision to that robot that is then controlled by that robot, that you can do incoming quality inspection and outgoing quality inspection, and you can get there at 100%. Plus, even if you have barcodes and lot codes, you're adding traceability. So for a very incremental part of your project outline, you can get a big bang for your buck. The other part is you can make this a staged process, because the idea here is engaging with automation in a staged process. So a lot of times when I was running a system integration operation, we might have 2 or 3 stages of implementation with that customer, where you're just doing a pick and place, but then you're going to add the vision and you're going to add more intelligence. You're going to add some flexibility to handle different product line. So there's a great use for robots when you're looking at a flexibility and taking a staged approach to where you want to go.
So here's a great question. Were you done, Daryl? I'm sorry, I didn't mean to interrupt.
Yes, I'm good.
Okay, so I don't know if Matthew's still with us, but he had a great question about how do you maintain the robots, and if one starts working, how quickly can a replacement be found and implemented? And then, in the interim, you have potentially lost revenue. So what are the implications? We like to envision these things working all the time, but as with any automation, there's potentially issues. What have you experienced there?
I can chime in real quick and say my favorite answer depends. Unfortunately, there is generally more than the robot on these systems. So speaking of from a robotic arm perspective, I do know that they are getting better at having the components be more modular to replace. So instead of having to send it back to a service factory, OEMs are improving their design so that they could be field replaceable. So theoretically, I know for one of our product lines, if you had the part on the shelf, you could actually swap in the new part within maybe half hour to an hour to allow you to be up and running. So generally the best practice is identify which parts are going to wear and tear first, have those on the shelf if needed, or just have an action plan to turn those around. Again, this is coming from a non-user perspective, but I do know that predictive maintenance, preventative maintenance, those measures are coming more and more as these components get more and more intelligent and understand their current status too. So in the future, I'd imagine you'd almost have a heads up whenever something is going bad. So that definitely is trending in a good way for these standardized robot type of platforms. But obviously the more moving parts, the more potential you have for failure. So simplicity is good there.
So this is another key part of when you're trying to consider collaborative robots versus high-speed industrial robots, is that collaborative robots are being deployed in a way that if something goes wrong with that robot and it's not operating, it's easy to pull that robot out of the operation and resume manual operation by an operator. That can happen very, very quickly. You don't have to have the spares or the backup robot. That transition can happen very easily in very low skill level. If you use a high-speed robotics, that's typically, let's say, even for a $50,000 high-speed robot, it's about an additional $250,000 of automation that goes around it. And if that robot goes down, there's typically not a way to move it out of the way. And they require, well, all robots do, but more intensely, a high-speed robot will require very precision remounting and replacement and reprogramming. So there is a gap there in the what we call cost of ownership between the collaborative and the high-speed. But the plus benefit of high-speed is the fact that it's high-speed. So you want to deploy that when you truly need the high-speed.
So I agree with everything that Daryl was saying. I would just only add, over the last 2.5 years with 8 collaborative robots, we were only down for 1 day on one of them because of a repair issue.
Mark, any thoughts?
One of the things that I look at it in terms of speed, I don't really look for speed because I'm a high mix, relatively low volume business, except for some of my components maybe. But, the idea of not going after speed and high volume for a high volume product makes your whole mind think differently in terms of how you implement the systems that we're talking about. So for me, I say that I'm more interested in the consistency and being up and running, but I'm not interested as much in the speed and the throughput. I tell you why. I mean, you all know this, but if you're not careful, you go home at night, you come back in the morning on night shift, and you find out they built a whole lot of scrap. So you gotta be careful about making sure you got the process monitors in place that you're when you're building and using robots, because they'll keep doing they would talk about Einstein's definition of insanity. They will do it again and again and again. So be careful with that.
Wow.
Well, Kent, you want to just go around one more time for some last comments?
Yeah, sure. Let's start with Mark. Any parting thoughts or wisdom you want to share with the group?
Hopefully, I shared most of what what I had to say. My advice is, and something I'd like you all just to write down and think about. Work on your future state first. Most people, when they build strategies or look at their business, they always hone in on what they're currently doing, and try to avoid that. Look at your future state first, and then and maybe in 3 years, say, what is that future state? What's your dream of that future state? And then you can take your current state and roadmap to it. It's a inverted way of most people in manufacturing only look at what they have, and then they do incremental improvements from there, but they don't see that future state they need to go to. That's one thing. The other thing is, we haven't mentioned COVID-19 and what impact that's having, but clearly the way in which we're running our businesses, the virtual reality that could and does exist, you know, how we can do training and education, how we can do you know, some of the implementations robotically, you know, starts to play into a more collaborative way of running a business where you're not necessarily in the same building at the same location. And so, you know, just kind of think about that. I'll leave you with that. There's a lot about that subject matter that is worthy of discussion. And then number 3, try to avoid getting into the return on investment trap and look at what's right for your business. Sometimes, you know, like training, I do a lot of training in my company, and I invest in a lot of training. I don't calculate the return on investment for training because I know it's the right thing to do. And sometimes you might want to think about what is the right thing to do for your company to take it to that future state. And I'll leave it with that.
Thanks very much. So I'm just going across the screen here. Nick, you're up next. Any parting thoughts?
Yeah, just to touch on the technology itself. So whether it's collaborative robotics or automation in general, just as Mark mentioned, to change your mindset about the ROI, kind of change your mindset about what these machines are. Think of them more as production or manufacturing tools, things that can be repurposed, can be utilized by your workforce to improve what they're doing. And number 2, like we all mentioned, invest in your workforce. So I'm out here selling robots, but people need to use them and know how to use them. Gary kind of mentioned it before, but whenever you have a team that you invest in and you see who is rising to the occasion, who is interested, definitely invest your time and effort in making sure that they're given the tools they need to succeed too. So I'm very human oriented. All our trainings are obviously, we do free trainings, investment supporting on-site programming, because our goal is to make you as powerful as you can be with these new types of technologies. So 1, treat them as tools. 2, invest in your workforce.
Fantastic, thanks. And then Gary, any last thoughts there?
Sure. You know, I concur with everything that Mark had just mentioned, and can't underscore it enough. The only thing from my perspective is really simple. I really agree with Mark in that ROI. The ROI is going to come. You know, don't get hung up on it. What I find is there's just a lot of reluctance on a lot of manufacturing to try something new. And when you look at it, if the investment is $50,000, $60,000, $70,000, just instinctively you know what needs to be done. And I would just say do it, get started. Because if you never make the decision to get started, you're never going to move towards improvement. That's really my final comment.
Fantastic. And Daryl, you're in the 4th slot, so you're cleanup. Bring us home.
All right. So I am going to circle right back to what Mark was saying. And when I would go to customers and start working on projects and be going through that functional specification development and process development, it is very important to ask, where do you think this is going to be in 5 years? And, you know, when I be looking at a machine tending application and you want that robot feeding the machine, a common question that I would come up is, well, who's going to feed the robot? Because sometimes people get trapped into the fact, okay, now the operator's just feeding the robot, and the gains were not necessarily looked at. Or a customer is looking at a mobile robot and they're having one operate in the facility and not taking into account 5 years from now, they want to have 10 operating in that facility. Then there's fleet control issues, traffic issues, and things like that. So very good thing to look at that 5-year window. And please value the part of the robot that makes it a very scalable, redeployable solution. So your risk is really minimized, and you can continue to use this to your advantage in your manufacturing. And probably third is look for those auxiliary value operations. For example, vision being used to do inspection, traceability, the ability to do line changes, because sometimes you automate the robot to do things over and over again, but then the robot has to be stopped if you're going to do a product change or a line change. But these can all be things that you stage into your journey into automation. So So that's kind of my last points for the day.
All right, Daryl, thanks. And thanks to all the panelists. It certainly made me smarter and I've enjoyed the journey and putting this together. So, and thanks to the audience, we still have several people on. Thank you for your attention. And Jeff, you want to close it out?
Yeah, that sounds great. And this was a great session, and we still have a lot of people hanging on, so we appreciate that. Thank you, Mark, Gary, Nick, Daryl, and Kent for sharing your knowledge today. Let's give everybody a virtual round of applause, right? They did a nice job. All right, I'm going to share my screen and put a little bit of information in here on Business Pros. So our group is organized to offer high quality educational content like today, and our 29 members are available to help business owners in just about any capacity. So if you have any questions about the resources our group provides, please contact me. We are putting together a series of webinars for the rest of the year. It'll work out to be about 2 a month, so through December. Our next webinar is Wednesday, August 12th, featuring Cheryl Powell and Michael Battaglia, and it's going to be titled The Benefit of Benefits, Increasing Engagement, Productivity, and Culture. And as we see small businesses entering their renewal season, this webinar will be structured to answer the most important questions that small business owners should be asking. That's Wednesday, August 12th. Save the date. Thank you, everyone, for taking time out of your day for this extended session, and make it a great day. Bye now.
Thank you all. Thanks, Jeff.
Good deal. Did Kent stay? I guess he didn't stay. Thank you, Mark. Appreciate your time today.
Okay.
Did you have something, Jeff? Did you want to add a question or comment?
No, I thought it was extremely well done. A good mix between the technology stuff done up front and then the applicability of it culturally, productivity, quality. I think a real good balance for someone that would be out there thinking about automating in some way and not having started down that path. I think you guys did a great job.
It's awesome. Yeah. Yeah. Thank you, Daryl. Really appreciate it. We
Thanks for the opportunity, Jeff. We appreciate it.
Yeah, and I'll include. I send an email out with the video, so all the people that registered will get a copy of the recording, and I'll include your contact information in there just in case anybody has any follow-up questions.
One point, I think for Daryl, I think the video that came across that people were watching from you was not good quality. So maybe you could resend that and it could be somehow integrated into the presentation.
Yeah, no, it's all in high def from this side. It just probably was internet
Yeah,
issues.
it's probably our machines.
Bandwidth.
Yeah.
It was across the board. Yeah, it didn't come through for some reason.
I do have I pre-recorded a version just because I was doing time and stuff anyway, so I do have it available in that format.
Yeah, just on a kind of you don't have to answer that. When do you guys set up shop near the airport and have your lab for people to go in and view things and concepts, et cetera?
We're going to be beginning that process towards the calendar fourth quarter.
Mm-hmm.
And then we probably will be in full operations within the first quarter of 2021. Obviously, the